Next part, that is nothing but essential and the desirable properties of the fiber it is there. So can any one of you will tell me what is the essential and what is the desirable or the difference between these two? Yes, any one of you? Essential means, see, whenever you are talking regarding the properties of the fiber, whenever you are going to take the fiber, it is there, that particular fiber must possesses these four properties. Means there must be a length and its variation must be there. Whatever the fiber which you are going to take, the strength must be there. Fiber must be a uniform in nature. It must have the spinability. Until and unless the fiber do not possess this property, will not take it for the manufacturing of the yarn or the fabric. Hmm? That's why these are the essential power. Desirable means with the fiber, whatever the essentiality there means the fiber must have these four properties. Until and unless these properties are not there, we cannot use this as a fiber. See, for example, if you take into consideration our human hair, see, human hair we cannot use as a fiber. No, we cannot use it for the manufacturing of the yarn, or we cannot use it for the manufacturing of the fabric. Why? Because they are not possessing these properties. Hmm? Next, when you are talking regarding the desirable properties, if these properties are present over there, that is well and good. It is more advantageous to have this type of the property, just like a fineness, resilience, capillary and the porosity, luster and the durability. So whatever the fibers which you are using, it is there currently. Some of the fiber is fine, some are coarser in nature, some of the fiber got the resiliency, some do not have. Some of the fiber they got the capillarity and the porosity, some do not have. Luster, it is there, or some of the fiber it is not there. Durability, it is there in some fiber, it is not there in some of the fiber. Means desirable property, if it is there, it will give the advantages to the fiber to have the additional property over there. Hmm. And now we are going to see all these properties, and based on this also we are going to perform some of our experiments also. So first property, that is nothing but the length and its variation it is there. So whenever you are talking regarding the textile fiber it is there, so this is the first and foremost property that we have to take into consideration. That is nothing but the whatever the fiber which you are going to get, it must have enough length. Hmm? So length is an important parameter which determines the usefulness of the textile fiber it is there. Hmm? Means if the fiber is too short, it is there. We cannot use it for the manufacturing of the yarn. We cannot use it for the manufacturing of the fabric. And if it is long, it is there. We are going to get the added advantage also. Hmm? Now, whenever you are talking regarding this particular fiber length and the its variation, it is there. Here we have to take into consideration more of this particularly our natural fiber. See, whatever the synthetic fiber which you are going to use it over there, no doubt synthetic fiber will have better length because not the synthetic, all the whatever the man-made fibers are there, that might be a regenerated or synthetic one or the inorganic fiber it is there. They will have the sufficient length which we can use it to convert it to the yarn form, or we can have it a continuous filament yarn, or we can use it for the manufacturing of the fabric also. That I'm talking regarding the non-woven fabric also. Hmm. So they got the sufficient this. But as far as the natural fibers are concerned, so in case of the natural fibers, whatever this property it is there, related to the length it is there, there's a tremendous variation it is there as far as the length is concerned. Because these things we are going to get naturally and we have to accept as it is. But in that also, see, whenever you are going to select the fiber it is there, we have to take care that whatever the fibers which are going to use it, it is there, this fiber, whether they got the sufficient length or not. And based on this, we have to decide whether we can use it for the manufacturing of the fine yarn, medium yarn, or the coarser yarn. Hmm? And whatever the yarn which you are going to get is property also is determined by the length it is there. Hmm? So when a continuous yarn is to be made out of the individual fiber, it should possess a considerable length with a reference to its diameter. Now, whenever you are going to take into consideration this particular point, here we have to take into consideration the diameter of the fiber also. Hmm? So whatever this particular thing it is there, it is generally regarded as the length to breadth ratio or L by D ratio. That is nothing but the length to diameter ratio it is there. Now whenever we are going to use the fibers for the manufacturing of the yarn or to make it a continuous yarn from the individual fiber, the minimum required ratio is L by D, that is nothing but the 100:1. That is the minimum required one it is there. Means, for example, suppose if the length is 100 mm and the diameter will be 1 mm, then that particularly the L by D ratio will get the 100 it is there. Hmm? But what are the almost textile fibers which are using it is there, naturally fibers which we got, they got this L by D ratio more than 1000 it is there. Now, for example, if you take into consideration the cotton fiber L by D ratio is a 1400. Wool fiber, that is the highest, again it is a 3000 it is there. Flax fiber, it is around 1. See, all these are the average, it is not a fixed L by D ratio. All these are, we have to take into consideration the average one. Flax fiber, we got the 1300, around 1300. Rami fiber, we got the 3000. Silk, it is a 33 into 10 raised to 6. That much it is there, because this is the only natural fiber which you are going to get into the continuous filament form it is there. That's why it got the highest L by D ratio as per the natural fiber is concerned. Natural, again in that we got the protein fiber it is there. Now if you see the classification of the natural cellulosic fiber, how we are classifying? We got the seed fiber, we got the bast fiber. Next category, we got the leaf fiber. Then next we got the fruit fiber. So these are the major four we'll take into consideration. Now out of this, if you see whatever this bast fiber and the leaf fiber are there, they got the high L by D ratio. Hmm. For example, flax and the rami, these are the bast fiber it is there, they got the high L by D ratio. If you consider this particularly the leaf fiber, they also got the high L by D ratio. Whatever the seed fiber it is there, the seed fiber and our fruit fiber it is there, they got the low L by D ratio amongst all this. Because see, on to the seed, what are the fibers which are going to get definite length is there, and that length you have to take it. In case of the fruit fiber, again, we are going to get on to the shell, whatever the square fiber it is there. Again, there also we got a definite length. But in case of the bus, and we can take into consideration the leaf fiber, whatever the length of the stem it is there. In case of the bus fiber, based on to the length, we can have the variation over there. That's why whatever this flax and the rami fiber it is there, they got the high L by D ratio it is there. The next that will be the leaf fiber will be there, and later on we got this our fruit fiber and the seed fiber it is there. Now if you compare with the again natural fiber, in that we got the animal protein fiber. If you compare this, silk got the highest one. Then second one, that is wool it is there. Now whenever you are considering the wool fiber, again there is a tremendous variation you will get it, because from which we got this fiber, whether it is from the sheep, whether it is from the goat, whether it is from the yak, rabbit, camel hair, from this source, again there will be the variation will be there. So right now, whatever the wool which is written, that we are going to get it from the sheep, and that particular value is written over there. It is not related to the yak, because yak again it got the highest length over there. That's why initially only I use the term that whatever these values are there, these values are written on an average values are written, not a fixed one. And you will get a variation over there also. And as I told you that based on this also we are going to perform one experiment, that is a measurement of the length of the fiber by using the grease plate method. In that we are going to check the length of the cotton and the wool fiber. Now, whenever you are considering this particular fiber, the length is the most important property of the fiber as per the ring spinning is concerned. Now, side by side, you are studying the spinning technology. Now, what are the various spinning technologies you are studying over there? Ring spinning. In a ring also, you might be seeing the, we got the carded yarn, combed yarn, compact yarn it is there. Along with the ring spinning, there is one more along with the ring spinning, there is a one more spinning technology that is open end. It is there. Now, if you consider, we just consider onto the ring spinning. It is there. See, as I told you, there are three different type of the yarns which we can have it from the ring spinning. That is a carded yarn, combed yarn, compact yarn. It is there. Now, if you see these yarns, carded yarn, you will get the more of the hairiness. Now, what is this hairiness? It is there. See, whatever these fibers, see, this is the yarn, it is there. And we are going to get the fibers coming out from this yarn structure. You can see over there. These are the fiber ends we are going to get it over there. And this is called that hairiness over there. These are the two different yarns. Now, added to that, whatever the spinning technologies are there, in case of the carded yarn, you will get such type of the more of the protruding fibers. If you consider the combed yarn, in combed yarn you will not get this much protruding fibers. Now why we will not get the in combed yarn this protruding fibers? In combed yarn there is one more additional process it is there that is called that combing it is there, in which we are removing the short fibers. Short fibers mean the fiber with the lesser length are removed at that stage. Now whenever you are removing this particularly the short fibers, whatever the yarn which you are going to get, that yarn will have the lesser hairiness will be there. Hmm? Again, if you consider the compact yarn rarely you will get such type of the protruding fibers over there. Hmm? So whenever you are carrying out the spinning, so as the fiber length increases, the overlapping of the fibers in the yarn increases. See, suppose now there is a in detail you study these things in a spinning. Suppose these are the fibers are there. Hmm, four fibers are there. So whenever I am going to carry out the spinning over there, sorry, see, suppose this is a definite length it is there. Now see, whenever I am going to carry out the spinning of this, what will happen? There will be the overlapping of the fibers will be there. The fibers will get overlapped to each other. As the length is larger, it is there, you will get a hardly the protruding fiber. But in this yarn, suppose there are the two fibers. Hmm, two fibers we got with of the shorter length. Now what will happen whenever you are carrying out the spinning? Spinning means what we are doing? We are carrying out the twisting of the fibers by means of the application of the external. Means here in spinning means conversion of the fibers into the yarns, or we can say the conversion of the visible polymeric chains into the yarn by means of the application of some external process, just like a twist and the draft it is there. So whenever you are carrying out this particular process, it is there. So here, whatever these fibers are there, they will get spin with each other. And whenever there is a twisting, it is there. What will happen? These fibers will get exhaust early, and we are going to get the protruding fibers over here. Why? Because these two fibers get exhausted early. That's why they will come out over here. But if the fiber got a good length over there, what will happen? There will be the proper overlapping. It is there, and we are going to get a yarn with a lesser hairiness over there. Another advantage we are going to get as there is a increase into the overlapping, or there is a more and more overlapping. It is there. There will be the resistance toward the slipping. Slipping means when you try to pull such type of the yarn over here, what will happen? As these two fibers are contributing lesser over here. So whatever the yarn it is there, the yarn will get easily break down over here. As compared the yarn where we got the all these fibers over here, because see all these fibers will contribute to the load which is applied over here, and the fibers got exhausted early. Whatever the load which you are applying it is there, this load will be contributed by the lesser number of fibers, and that's why there is a more slippage it is there as compared to this. Hmm? So if the yarn is spun from long and the short fiber, then the yarn spun from the long fibers will have the more strength because more energy is required to break down this. Whereas over here, less energy is required to break down this. Clear? Now, whatever this variation it is there, see, as I told that the fibers we are going to get naturally over here. So in case of the cotton fiber, whatever the variation it is there, we can have the as maximum as a 40% variation over there. Whereas in case of the wool, there is a maximum acceptable range that is a 50% it is there. I think you have studied the CV, coefficient of variation. Yes or no?
Yes, sir.
No, sir.
You have studied the coefficient of variation is in acceptable in case of the cotton that is a 40%, whereas in case of the wool that is acceptable range is a 50%. Means here as we are going to perform practically also, if whatever the fiber sample we are going to take it over there for the measurement of the length, and in that see we have to measure the mean length of the fiber sample, you have to measure the standard deviation, you have to check the coefficient of variation. Now, whatever the CV which you are going to get, if this CV value, coefficient of variation is more than 40% in case of the cotton, then we should not access such type of the fibers. And in case of the wool, if this value is more than 50% it is there, then we should not accept such type of the fibers for the spinning purpose. So this will give the idea that see whatever the fibers which are going to use it for the spinning purpose, whether this fiber we can use it to convert it into the yarn or not. The CV percent is more, it is there, more and more CV percent it is there, we are going to get a more and more irregularity in a yarn. So that's the case with the length and variation. Now, whenever you are talking regarding the man-made fiber, see man-made fibers are uniform because whenever you are going to convert these filaments, so there is we got the bundle of filaments over there that you have to use the term as a toe, and we are cutting this toe to a definite length around 45 that is a common use length it is there. Now here whatever these fibers which are going to get it over there, this fibers length will be the uniform. Just like in case of the natural fiber, we are going to get a tremendous variation. Such type of the variation you will not get in case of the man-made fibers. That's why man-made fibers we are going to get it uniform. So length uniformity does affect the yarn irregularity and the strength it is there. Now, when you are considering this particular point, now how this point is useful for us as a processor? Can anyone tell me as a processor why this point is more important? Yes, any one of you? Huh? As a processor, whatever this length and this variation, why it is important for us? Why you are studying this point? Am I audible
Hello.
to you? Yes, yes, yes,
Yes,
yes.
sir.
I'm getting. Yes,
So the
Alok.
protruding fiber may give bad effect on dyeing.
Okay, and only in dying. What effect will get it? Yes, Alok.
Uneven effect, sir.
Uneven effect. Okay. Any other answer?
Sir, in printing also.
Yes, good. In printing also. Yes, in printing, what type of the problem will face it? Yes, correct. Who has given the answer?
Sir, during printing, yes, sir. During
Yes, Alok.
printing,
Yes.
the protruding fiber will overlap the main fabric,
Mm,
and because of that, if in case of screen printing, sir, the
yes.
print paste will be stick on the protruding fiber.
Yes, correct, correct. And what one more problem we'll face? That
And
we
sir,
will not find it.
there
Yes.
will be no design on the main fabric, sir.
Okay, there will be uneven design. Now we will not have any sharp outline. Suppose this is my design, it is there. Hmm? I'm not good in a drawing as good as you. Suppose this is one of the smiley. Smiley means it must smile, na? Ah. Suppose this is a smiley which I want to print onto the fabric, it is there. Now suppose now plain fabric it is there, you will get the definite outline over there. But suppose there are protruding fibers are there, so what will happen? This outline will not be a sharp. Why? Because there are protruding fibers are there which we call the haziness over here. Hmm? So this will give the unpleasant appearance to the print it is there. I will not have the clear outline of the design it is there. So that's the problem we are going to face. So what the solution for this? You are studying right now in a TOPT1 also. Huh? What they
The
think?
singeing.
Yes, correct. So solution for this
Singeing,
is,
sir.
yeah, we got the singeing
Singe.
over this. So whenever you are carrying out the singeing, what we are doing, whatever these protruding fibers are, these protruding fibers we are burning, and we are going to get a clear look of the fabric. Hmm? So that whatever the print which you are going to get, that print will be a clear design will be there. No any haziness or the clear outline. We are going to get it over there. See how the things are related with the processing. Hmm? That's why see whenever we are going to get the fabric from such type of the, see how we have to decide. See when we got the fabric whether it is required to carry out the cinching or not. When you can see the appearance of the fabric, hmm, by seeing the appearance of the fabric we can easily come to know. Now in that fabric what we have to check whether there are more of the protruding fibers or not present or not. If more of the protruding fibers are there, we have to carry out the singeing over there. And if we know that particular fabric yarn which you are going to get, hmm, there's a particularly the carded yarn it is there. No doubt we are going to get a protruding fibers over there. But in that particular fabric, if we got the combed yarn or the compact yarn, very rarely we need to perform this operation. So clear these points. Length and its variation.
Yes, sir.
Okay. Now we'll move to the next property, that is the strength. Hmm, okay. So strength indicates the resistance of the sustain by the fibers. Sorry, it's a yarn. It is there actually yarns or the fabric to break when the force is applied to them. Hmm. So strength indicates that whatever the resistance means. Suppose now here we got the fibers. This yarn is there or the fibers is there. Hmm. There are the more of the yarns we got it. Hmm. Fibers are there in this yarn. Now what does it indicate? It indicates the resistance sustained by the fibers or yarn or fabric to the break when the force is applied. Suppose this is a yarn, it is there. If this yarn get break down very easily, what does it indicate? That yarn got the force state. But if whatever the force which is applied, if this force is required to be more, it is there. What does it indicate? Whatever the yarn it is there, the yarn got a good state. Now, whatever this property it is there, the strength we can measure it for the fiber also, yarn also, as well as the fabric also. Hmm? Now, whatever the strength property it is there, see strength we are measuring in a different terms. That tensile strength, bending strength, bursting strength, etc. We are checking it is there. Even one more, that is the tear strength of the fabric. We are checking it is there. Now all this, whatever the tensile, bending, bursting, it depends on the direction of application. Now tensile means suppose right now this is a fiber, it is there. If you are applying parallel to the fiber axis, then that is a tensile. Bending means if you are applying over here. Bursting, it is applicable to the fabric. Means suppose this is a fabric, it is there. Hmm. And when you are applying the pressure over here, so it is overall in all direction we are applying, that is a bursting strength it is there. Hmm. So in which direction we are applying this particular force, that will be decided. Even suppose this is our fabric, it is there. If to this fabric, if you are applying the pressure over here, hmm, means perpendicular to the fabric. If you are applying, that is called a tear strength. So in textile processing, generally we prefer to check the tear strength as well as the tensile strength of the fabric. Bursting strength, we are checking it for the our knitted fabric. Because for bursting knitted fabric, it is difficult to check the tensile strength because when you are applying the force, we are going to get more of the elongation. That's why instead of testing the tensile strength, we are going to check the bursting strength of the fabric. In detail, you are going to study all these properties in a third year. We got the textile testing subject. In that also, again, you are going to study all these things in detail. I am going to tell you just what are the important properties that is essential and the desirable properties of the fiber it is there. So you'll not go to details regarding how it tastes, what are the its effect, everything. So fiber strength and the elongation have the direct relation with the yarn strength and the elongation. Another thing being constant, it is there. Hmm? The stronger the fiber results in a stronger yarn, and same is true about the fiber elongation. Next, normally the strength of the textile fiber is measured in a tension when the fiber is loaded along its long axis and designated as a tensile strength. Means normally the strength of the textile fiber is mentioned in a tension. So how much tension we are applying to the fiber along its axis. See, this is a fiber. And what we are doing, we are applying along the length of the fiber axis, not the, means it is parallel to the fiber axis, not the perpendicular. And whatever this thing it is there, that is called a tensile strength it is there. So tensile strength of the textile fiber is measured as the maximum tensile stress in a force per unit cross-sectional area or per unit linear density at the time of the rupture is called a tenacity. So whatever the strength of the fiber or fabric it is there, it is measured generally in a tenacity. So tenacity means it is a tensile strength or textile measured in a maximum tensile strain in a force per unit cross-sectional area. Now see, this is a force per unit. Suppose if this thing is changing, length is same, but the diameter is changing, no doubt, whatever the tenacity of the fiber it is there, the tenacity is also going to change it is there. Because it's a per unit cross-sectional area. As the cross-section is going increasing more and more, tensile stress in force we need to apply to the fiber. See, but necessary as the diameter is increases mean more number of the polymeric chains are contributing over there. And that's why more energy is required to break down this. So that's the indication of the tenacity it is there. And tenacity is expressed in terms of grams per denier. Now, for example, if you see the tenacity of the cotton fiber, it is in the range of 4.3 to 4.5 gram per denier it is there. And so that the tenacity we are experiencing. And another unit we are using that is nothing but the grams per text. Generally, it is used for the synthetic fiber. And for natural fiber, generally we prefer to use the gram per denier. Even see gram per denier, we can use it to synthetic fiber also. We can express in a GPD or gram per text also. But most commonly preferred unit that is nothing but the gram per denier it is there. That we are using the term as a GPD. Short form we are writing GPD, but actually it is a gram per denier it is there, the tenacity. Then third property that is nothing but the uniformity it is there. Uniformity means evenness of the individual fiber in its length and the diameter. See, now we got the fiber. Now see, here I am showing you. Okay, you can see over here one more diagram. Now can any one of you tell me which one is a more uniform? Yes, any one of you, though it is related to the other property, but can any one of you tell me out of these? See, these are the three fiber. Okay, just consider these two fiber, cotton and this is a polyester. It is there. Out of this, which one is more uniform? What is the polyester? It is there. It is more uniform. Why? Because what are the diameter? It is the diameter at this point, diameter at this point, diameter at this. Any of the point is same. Whereas over here, diameter at this point, diameter at this point, diameter at this point is a different it is there. So natural fiber got the less evenness, uniformity as compared to the synthetic fiber. Hmm? So uniformity means evenness of the individual fiber in its length and the diameter it is there. And the fiber possesses this property can produce the reasonably even yarn. See, if the lesser and lesser is a variation in the length as well as the diameter of the fiber it is there, whatever the yarn which you are going to get, that yarn will be more uniform it is there, which you will get the lesser thick thin places in the yarn. Hmm? I think you have seen the slub yarn. Have you seen the slub yarn? Khadi fabric, you have seen? Yes,
Yes, sir.
khadi fabric you have seen. See, in the khadi fabric, if you see, there is a more of the variation. Now we are going to more of the thick and the thin places in a yarn. Hmm? And that is because of the non-uniformity it is there, because whatever the yarn which is there, which is manufactured over there, that is uneven yarn it is there. Hmm? We are going to more of the thick and the thin places over there. For example, say suppose this is a yarn it is there. Now you can see over here that this is a thin place, this is a more thick place, because of which whatever the yarn or the fabric which you are going to get in that yarn or the fabric, there is a more of the non-uniformity. It is or this is a not uniformity is there. Hmm? So uniform textile fabric should possess the uniformity in a thickness as well as in a length it is there. Hmm? And natural fibers, just like you can say cotton, wool, do not have the same length and the diameter. For example, if you see the most of the natural fiber that tapering at the end. Suppose if this is a cotton fiber, hmm, broader at the end where it is attached to the seed and becoming narrower at the tip. Similar case with the wool fiber also. Wool fiber, there are scales are there. See, wool fiber structure is just like our human ear. If you see the human ear, they are broader at a bottom, hmm, whereas they are becoming narrower at the top, because there is a variation in the length as well as the diameter it is there. Even see we will not have the same length also. We have seen first property that is length and its variation. So there is a tremendous variation as far the length is concerned. Mm. But in case of the synthetic fiber, the man-made staple fibers are more uniform as they are cut to the exact length after being spun and drawn. And even the diameter can be controlled within the cloth tolerance limit during its manufacturing. As I told you, if you see over here, this is one of the synthetic fiber where this particularly the thickness is same everywhere. Whereas in case of the natural fiber, there is a tremendous variation it is there. Hmm? Now, whenever you are talking regarding the man-made fiber, again, whatever all regenerated fiber, all whatever our you can take into consideration this synthetic fiber or mineral fiber that might be a glass or polyester or viscose yarn, all will have the uniformity. Hmm? If more and more uniform fibers we are going to get, whatever the yarn or the fabric which are manufacturing from that will be of more uniform in nature. Next, that is nothing but the spinability is there. Hmm? So spinability includes the several physical properties which having an effect on to the ability of the fiber to spun into the yarn or not. Hmm? Means whatever the fibers you see, we got a tremendous number of fibers are naturally available. Hmm? Tremendous. But whatever the fibers are, they see all these fibers we cannot use it for the manufacturing or to convert it into the yarn form. As I told you that the simple example, our human ear. Human ear we cannot use it hmm, to convert it to the yarn form. See, wool fiber we can use it, but not the our human ear. Now, why human hair we cannot use it? The reason behind it that because of the lack of the spinability it is there. Now, whenever you are considering the spinability of the fiber, it is there. We have to take into consideration the two main characteristics under the spinability. One, that is nothing but the flexibility, and second, that is nothing but the cohesiveness. See, again in a fiber, not only this, if it got the both these characteristics under the spinability, that means it must have the flexibility also, and it must have the cohesiveness also. So they must have the certain degree of the friction, that is nothing but the cohesiveness again to one another to stay in the place when the pull is applied to the yarn. Now human hair, I'll tell you the example. Human hair. So human hairs are flexible. We can take it, we can twist it, but they are lacking in a cohesiveness. Means whatever these fibers are there, see these fibers do not get cohesive. Cohesive means they do not have interaction between each other. And that's why see human hair we can easily separate it also. Even if there is an entanglement, it is there. We can easily, when you are carrying out the combing, it is there, it will get easily separate out. Why? Because there is a lack of the cohesiveness between the fibers, it is there. That's why human hair we cannot use it to convert into the yarn palm. Now, when you are considering this particular point, whatever the natural fibers are there, these natural fibers got a good spinability as compared to the synthetic fibers one. So they must also able to take the whole special finishes for the lubrication during the spinning or on to the provide additional surface resistance toward the abrasion. Now coming toward this particular point, that is nothing but the flexibility and the cohesiveness. So flexibility means the fiber should be sufficiently pliable, then only it can be wrapped around another fiber during the spinning. Just consider the glass rod, like glass rod you have seen. Glass rod are not flexible because it is a stiffer in nature. So if on the other hand the fiber, if it is a stiffer, it is there, then they are less adaptable for the textile use. For example, glass or the metallic fibers, and because they are lacking in a flexibility. Whereas other fibers, if you see natural fiber, they are sufficiently flexible in nature. It is there. That's why we can easily convert it into the yarn form. Next, cohesiveness. Cohesiveness is a property of the clinging or sticking together in a mass. That is nothing but the coming together. And synthetic fiber, they are lacking in a cohesiveness. So it is a property of the individual fiber. Now, just check over here. See, instead of over here, I put it over here. See, these are the natural fibers. Can you see the images? Cotton, this is a wool, this is a polyester. Now, cotton fiber, see, these are convolutions are there. And this is a twist-like structure. It is there. This is called as convolutions. In case of the wool fiber, there are scale-like structure. It is there. Scales are there. Whereas in case of the polyester, nylon, or we can see the synthetic fiber, we are going to get a rod-like structure. Because of this rod-like structure, see, when you want to convert it into the yarn form, see these, because of the twist, when you are bringing the fibers together, cotton fiber we can see, always we are going to get in a group. So we can easily carry out the twisting over there. Wool fiber, because of these scales, they get entangled with each other and we are going to get a good cohesiveness over there. Also, one more point, see, in case of the wool, there is a crimp is there. Crimp is nothing but the naturally waviness is there in case of the wool fiber, which is lacking in our human hair. And because of this natural waviness, or that is called as crimp, we can easily carry out the spinning. Because of this crimp only, we got the waviness over there. Now, what about the synthetic fiber? So in case of the synthetic fiber, what we are doing, we are imparting this crimp mechanically, means whatever this bundle of the synthetic fiber it is there, We have to pass it between the toothed gears. Oh. So there is a gear, it is there. One gear, second gear. And there are gear, gear like structure, it is there. So they are heated one. And we have to pass these filaments over there through this. Now, as these polymers are thermoplastic in nature, what will happen because of this gear? We are going to get the waviness over there. And this is called a crimp. And this crimp we are bringing artificially. So that whatever the synthetic fiber it is there, in synthetic fiber, there will be increase into the cohesiveness. So cohesiveness is a property of clinging or sticking together in a mass, and it is a property of the individual fiber by virtue of which the fibers hold one onto another when the fiber is spun into the yarn. So wool fibers have the scales onto the surface and easily catch to one another when several fibers there twisted together during the spinning. Where in case of the cotton, as I told that there are convolutions are there and the fibers interlock themselves by the friction when they are spun into the yarn. And the introduction of the crimp in a synthetic fiber increases the cohesiveness. So like this, what we have to do, we have to impart the crimps in a fiber so that there will be the increase into the cohesiveness. Clear? So these are the four essential properties of the fiber it is there. So which are these four? One, length and its variation. Second, that is nothing but, yes, second property,
Strength.
Strength. Third property,
Continuity.
uniformity. Fourth one,
Uniformity.
yeah, uniformity, correct. And fourth one, that is nothing but the spinability.
Spinability.
Yes, under the spinability, 2 points we need to explain. That is nothing but whatever the fibers are there, it must have the flexibility as well as the cohesiveness. If flexibility is
Cohesiveness.
there, cohesiveness is not there, no use. Means what we require both these characteristics, flexibility as well as the cohesiveness. Then only we can easily convert it into the yarn form, that is nothing but the spinability. So these are the four essential properties. Next, that is nothing but the, we'll see only the one desirable property and we'll stop here. Next, that is nothing but the fineness of the fiber. So fineness of the fiber is a relative measure of the thickness or the diameter of the fiber. And the diameter measurement of the textile fiber and yarn is not possible because of the compressibility nature and its non-uniformity in the diameter throughout its length. Therefore, the textile fiber fineness is expressed in terms of the linear density. It is measured in terms of the linear density. Why? Because see, whenever you want to measure the diameter, say fineness is nothing but the diameter of the fiber. See, suppose this is a fiber, it is there. When you are applying load, see if I want to measure the thickness, it is there. How it is possible? We need to put something over here. But whenever you want to put something over here, what will happen? It get compressed. That's why it is difficult. Second, in case of the natural fiber, we have seen, they are non-uniform. So again, it is difficult to measure the diameter. No doubt in case of the synthetic fiber, we'll get the even diameter. But again, they are also compressible. So it is difficult for us to measure the diameter it is there of the fiber. So if the fiber is a finer, then more number of fibers in a cross section, which will make it more surface area available for interfiber friction, and thus will provide more resistance toward the slippage. Now, if you see over here, these are the two different. Just consider this is a yarn cross section. Same we have taken. Instead of circular, I have taken one rectangle over here. So that the point will be clear to you. So what we got instead of circular, I have taken a rectangle. Now, if the fiber diameter is smaller, so here what will happen? More and more number of fibers will contribute in a given area. And if fiber diameter is larger, what will happen? Lesser number of fibers will be there in a given area. So if the fiber is finer, then there will be more number of fibers in a yarn cross section will be there, which will make it more surface area available. Why we'll get a more surface area? Because individual fiber will have the surface area, and finer means we are going to get more and more surface area which are available for the interfiber friction, and this will make the fiber more resistance to the slippage. And due to this fact, the yarns have the same count. And yarn spun from the coarser and the finer yarn. The yarn from the spun from the finer yarn will have the higher strength as compared to the yarn which is manufactured from the coarser. Because over here, see, whenever the load is applied, see, this much number of the fibers will contribute to the load which is applied. Whereas here, as there is a lesser number of fibers are there, that's why whenever the load is applied, this load will be contributed by only these fibers, lesser number of fibers. That's why if we got the two yarns where we got the same diameter, yarn diameter I'm talking, in one yarn, we got a more number of fibers. In one yarn, we got a lesser number of fibers, so that whenever we are measuring the strength of these fibers, what will happen? This much number of fibers are there, more fibers are there. And we will get a more strength. Whereas over here, lesser number of fibers will be there because of the larger diameter. And this yarn will have the lesser strength over there. Now, whatever the fineness of the fiber it is there, in case of the cotton, it is expressed in terms of the microgram per inch, or another unit that is nothing but the micronear it is there. And in case of the wool and the man-made fiber, it is measured in terms of the text or denier it is there. So this is regarding the fineness of the fiber it is there. Clear the things? Any doubt regarding this point? Yes?
No, sir.
Okay. So today we'll stop here. If you doubt, we'll continue for a couple of minutes for the doubt clearation.